Okay, so to identify the following as linear, exponential, quadratic, or none, so we've got several different representations here. We have a graph with just dots, so a discrete graph. We've got some equations, some tables. We've got all kinds of different representations here. So we need to know which representation goes with what. So we do know that what we've been studying has been those quadratics. So quadratics have linear growth. They have an x squared, or somewhere an x times x in the explicit equation. And they have a linear amount added in the recursive. Their second rate of change is constant, but their first rate of change is linear, so that means in the recursive function it's linear. So we also have linear that you learned about last year probably, and we've been reviewing this year. So linear has constant growth or a constant difference, which means it's always the same. It adds the same number each time. Sorry. It has no exponents whatsoever in the recursive. That's right, in the explicit, or the recursive actually, in explicit. And the recursive, just adds the same number. So it adds whatever that common difference is after the f of x equals f of x minus 1, and it makes a line in the graph. The exponential it has a common ratio, which means it's multiplying. And it does have an exponent. And it's x. This is what we were working on last chapter when we were doing the tables and doing like x thirds, x fourths. Those were all exponential because it was multiplying. The recursive has something times that r. So f of x equals f of x minus 1, and then it's multiplied by r. And it makes a ramp almost on the graph because it goes very small to very big because it's multiplying. And when you multiply small numbers, they stay very small. And once you get bigger than 1, it multiplies very quickly. So if we look at problem 1, this makes that parabola shape. It goes down and back up. And if you look at the dots on the graph, you're like, oh, here's a half. So we went from 0, so it added 1/2, and from here to here it added 1.5. And from here to here, it added 1, 2.5. So it's adding a half more each time. So its rate of change is linear. So this is quadratic. Okay, number 2, I look at it and I go, let's start by seeing if it makes a line. And so I go, if I connect this and then this and then this, that doesn't make a very good line. So I don't really want that one. It's not linear, and I say, okay, maybe it's quadratic, maybe it's adding in a linear pattern. So I go, okay, from here to here, it added 3, and then 1, 2, 3, 4, it added 5. Totally looks like it's doing something, and then 2. Well, that's not going in a linear pattern, so, and it's definitely not multiplying by something because it was 7, 10, 15. Yeah, that's not multiplying by anything, so this is none of the above. Okay. So that's what you're doing on this one. You have notes from yesterday, you have notes from earlier in the chapter, but that's kind of how you do it in the first couple, so you could finish that out. Number 5 is always a little bit trickier, but look right here, you do have an x thing times another x thing. So when we multiply two things that are x, think about that. And then if you're going to say something about first and second differences, actually calculate them and then calculate those second differences as well.